Hello everyone, nice to meet you. I'm Era, making humanity a multi-planetary species. Elon Musk's highly ambitious Mars colonization project was presented in more detail in a presentation that lasted roughly 40 minutes. Thanks to Star, we had a live stream, and I'll be breaking down the specifics of the technologies discussed, going through each point one by one. A lot of technical details were covered, and the content itself is really fascinating and just plain fun to listen to, you know. Regardless of whether it actually happens or not, rather than debating that right now, Elon Musk specifically stated that he plans to launch in 2026 and then actually arrive on Mars in 2027. He even mentioned that specific detail. How these plans come together and what SpaceX's specific strategies are, especially considering the absolute necessity of sustaining human life on Mars. So let's examine in detail what precisely needs to be accomplished for humans to survive and thrive on the journey to and eventually on Mars itself. Initially, Elon Musk outlined SpaceX's ultimate objective, which is to relocate human civilization and life to a different planet for the very first time in history. He says this is the first time in Earth's 4.5 billion year history, and the mission is quite clear. He always says that the true measure of progress is establishing a self-sustaining civilization on Mars. This is something he talks about constantly, you know. Elon Musk consistently states that for humanity's long-term progress, we must be a multi-planetary civilization, not confined to one planet. He argues that a multi-planetary existence is essential for enduring advancement, unlike being limited to just one world. This is his exact wording. He says it will greatly increase our chances of survival. That indicates he's genuinely serious about it. Because, as you know, unforeseen catastrophes can certainly occur. Right now, Earth is facing various problems, and something could suddenly overturn everything. So, we need to be prepared for such possibilities. Therefore, as a vision to safeguard humanity, it's not just Mars, but also the Moon, asteroids, and Jupiter's substantial moons as well. The ultimate goal is to reach other planetary systems and even distant star systems. So, it's more than just being a company that builds rockets. They are presenting a truly grand vision meant to fundamentally change the entire future of humanity. Of course, some individuals might dismiss this as being completely far-fetched or unrealistic. Now, many people criticize it like this, but at least in this particular announcement, Elon Musk clearly presented that very vision. And regarding the survival of humanity, you could say he's chosen to diversify the risks with this particular portfolio. So what you're looking at right now is a visualization depicting transportation between Mars and Earth. This vertical axis here indicates Earth. It begins at Earth and then proceeds to Mars. The horizontal axis, starting in the year 2026 and extending all the way to 2034, displays a blue line which represents the journeys from our planet Earth over to Mars, and you are able to observe that the total number of these transportation trips is progressively becoming much larger. It appears there will be significantly more travel, initially from Earth to Mars, and subsequently, the frequency of journeys returning from Mars to Earth will also significantly rise. Therefore, if it is sent up at the very end of 2026, it will reach its destination in the year 2027. This means that it does take a considerable amount of time for the journey itself. So, the objective for the year 2026 is primarily to demonstrate our capability to reach Mars, and also crucially, to effectively showcase the essential technologies that are required both for the journey and for the successful landing. At that particular time, they even mentioned their plans to send the Optimus humanoid robot there. Following that, the landers, which are the actual landing craft, are projected to increase in number from 5 to 20, then 100, and potentially up to 500. This clearly indicates an incredibly large scale of operation. And for each of these devices, the payload, that is to say the cargo they can carry, is targeted to increase from 10 tons to 75 tons, 150 tons, and 300 tons. Then, around 2030 or 2031, they plan to actually mine those resources. This means they plan to use the resources available on site. And they're talking about setting up a happy habitat. That is, a space for people to actually live, a residential area. This is for the 2030s. They'll also need to generate energy for power. It's not just one or two things. There are a tremendous number of tasks to accomplish. They will have to move everything there because there is absolutely nothing there except for minerals. The priority will be to develop the technology to use the available resources. And lastly, we have global mobility and global communication. Now, the use of the word global here, when considering the context of Mars, suggests the intention to establish both mobility and communication systems across the entire Martian globe. The reason going to Mars is possible is because they've been continuously developing Starbase and Starship. Even just with Starbase, a rocket factory was built in Texas in roughly about 5 or 6 years, and now the launch pad is also being constructed. It's situated so close to regular public roads that literally anyone can see the rockets and the factory up close. Usually, space development facilities are isolated, but by 2019 Starbase had advanced hugely, and by 2025 it developed even more significantly. You can see how quickly it's progressing. So fundamentally, the entire process of designing the rocket, then actually building it, followed by testing it and sending it up, all happens in one centralized location, Starbase. Elon Musk is quite skilled at this kind of integrated approach, wouldn't you agree? Vertical integration and consolidating everything in one place to maximize production efficiency, speeding up tests and accelerating the process, that's what's happening. The reason SpaceX was able to achieve what it has is because, with the Falcon rocket, they successfully developed the technology to launch it and then bring it back down to land, which means they could reuse the rocket. This dramatically lowered the expenses associated with launching rockets. But with the Super Heavy, the largest rocket booster in human history designed to go to Mars, they're also aiming to reuse it. This process is often referred to as chopsticks. They are constantly testing this chopsticks method to catch the booster every time. Elon Musk really emphasizes 3 specific things: that it's rapidly reusable and reliable. He wants to make the process of building and and launching rockets rapidly, reusable, and highly reliable, you see. So, originally, this Starship system consists of two main parts. The front section, which is the Starship itself, and the rear booster component, known as the Super Heavy. This Super Heavy part that propels it skyward, pushes it up, and then returns. And as you can see now, they capture it using those chopsticks visible there. This is the method that enables its reuse. When it was first captured, I actually provided live commentary on it and even created a video that I uploaded for you all to see. We've shown how those massive arms on the launch tower, which are commonly referred to as the chopsticks, are utilized to precisely grasp and secure it. So when they recover that booster, it's not just discarded into the ocean. In fact, no other company has ever really attempted something like this before. But they bring it back and rapidly refurbish it, allowing it to be ready for another launch straight away from that stage. But what's also quite interesting is that the Starship's main body itself is also rumored to be reusable. Not the Super Heavy, but that Starship over there. It still hasn't been perfectly demonstrated yet. But they're aiming to demonstrate it by the end of this year or in a few months. That one is also a structure that is caught by the arms, and the one that is launched from the front is designed to be reflown multiple times a day, so testing this is a very big technical challenge. Actually, even during the live presentation itself, they specifically talked about how the most challenging aspect of making this Starship, the ship part, reusable again, is whether it can withstand the extremely intense heat generated when re-entering the Earth's atmosphere. That's the crucial point. So, they've referred to this as the reusable orbital heat shield, and the crucial question is whether they have genuinely acquired the essential technological know-how for it. As I mentioned when it was important, it's likely traveling at speeds considerably faster than the speed of sound. It's moving incredibly fast, exceeding Mach 25 at nearly 30,000 kilometers per hour, and as the Starship re-enters the atmosphere after being in outer space, it's hitting and colliding with the air particles at high speed. Then it starts creating plasma because of the friction with the air molecules, and the front part of the Starship compresses the air very rapidly. This process generates an enormous amount of heat, causing temperatures to soar to thousands of degrees, and the crucial question is how effectively the spacecraft can endure these extreme conditions, especially on Mars, where the main component of the atmosphere is carbon dioxide. If this carbon dioxide turns into plasma, oxygen atoms will be separated out. This oxygen will attempt to oxidize the heat shield, especially since the oxygen is still present, so it will attempt to burn or corrode it, making it a significantly more challenging environment than here on Earth. Just testing it on Earth simply isn't sufficient. So now they are simulating the Martian environment, the atmosphere, to conduct tests. For these experiments to be successful, the testing has to be done perfectly. It's an incredibly large spacecraft, you see, and since we do not know what changes might occur out in space, we really need to test it with various scenarios. Next, there's something they call propellant transfer, and what that means is transferring propellant while it's in orbit. They will need to refuel it because one single ship simply will not carry enough fuel to travel all the way to Mars or even into deep space beyond that point. So, just like airplanes refuel mid-air, the spacecraft will transfer fuel and oxidizer in orbit. This is a technology where two starships meet, with one essentially acting as a tanker, carrying and transferring the fuel and oxidizer to the other spacecraft. The majority of the propellant that is transferred will consist of oxygen. This particular feat has not yet been attempted before. First off, the very idea of doing something like this with such large starships is quite a bold attempt, and they're saying that these kinds of things need to be done to be able to go much farther. They're aiming for a technology demonstration by 2026 next year. It's not something that just came up. They've been preparing for it all along, you see. They're just revealing it to the public now, that's all. Especially if you consider why this is so challenging. The rocket must first escape Earth's gravity to reach orbit, which inherently uses up a lot of fuel. And as you can observe, it is currently in a state of zero gravity. In a zero gravity environment, they need to be positioned smoothly. But in space, liquids typically float freely or adhere unevenly to the walls of the container. This presents a significant challenge for precise placement. So, precisely transferring things like liquid methane or oxidizers such as methalox is going to be a really challenging task indeed. So it's being said that not only the technology for docking two of them is important, but the technology to properly refuel them is also extremely crucial. And I've heard some things about this new Raptor 3 engine, which I found quite interesting. The most recent iteration is the Raptor 3. They are saying it's been significantly upgraded, and it's designed in such a way that it doesn't even require a basic heat shield. The engine's flames are directly exposed, but it is designed to withstand that intense heat. The absence of a heat shield inherently reduces mass, so if they can enhance reliability, it will pose less danger even in the event of a fuel leak. They are progressively simplifying the design by integrating the internal structure for a more robust and efficient configuration. By reducing these elements one by one, it increases the potential to carry much more payload. First off, the Starship uses methane as its fuel source, which is cleaner than traditional fuels like kerosene. Essentially, it produces significantly less soot buildup. And also, as I've mentioned to you previously, Mars has a lot of carbon dioxide. And because there's a lot of water ice, this fuel was designed with the idea that it could be produced locally. So they are actively examining the possibility of recycling all of the necessary fuel and oxidizers directly on Mars itself, which is something that holds considerable promise and is quite exciting. Not only the Raptor engine, but also a new Starship, the Starship version 3, has been introduced. The next version of the Starship currently in development is version 3, which is expected to be the main one for Mars missions. Once it reaches a certain orbit, there's something called hot staging, as I always mentioned. The front part, the Starship section, and the booster, the Super Heavy section, separate. With hot staging, it slightly gimbals, the engines kind of spread apart, and it smoothly detaches and comes out like this. Basically, the booster engines ignite, and then the Starship engines ignite simultaneously during what's known as hot staging. It's designed so the flames can exit properly, and the interstage structure has been improved even further. Currently, the Starship is equipped with 6 engines, as you are probably well aware. However, the future version is actually planned to come equipped with a total of 9 Raptor 3 engines. So, this version 3 is targeted to include all the most basic, fundamental, and essential elements necessary for survival on Mars, such as reusability, reliability, and orbital refueling. All of these are expected to be built into this version, and they are aiming for the first launch by the end of this year. And the Starship is expected to become even larger. It's already quite big, but it is planned to grow by approximately 20 more meters. You can see here that the ship itself will go from 50 meters to 60, even 61 meters. And you can see the booster will also increase from 71 meters to 80 meters in height. This is how the 9 Raptor engines appear when installed. And then there's the transfer window for Mars. They talk about using this transfer window, but it's much easier to explain it like this. From Earth, you launch the rocket, and then it goes on its way. When Earth and Mars are in their orbits and are in a configuration where they're closest to each other, that's when they aim to launch to save as much fuel as possible and arrive safely. That specific concept is precisely what's known as the transfer window. As you know, Earth and Mars orbit the Sun at different speeds and at different distances. The most fuel-efficient way, which is what we're talking about here, is known as the Hohmann transfer orbit. This is a path where a spacecraft starting from Earth's orbit travels along an elliptical trajectory, precisely intersecting with Mars's orbit. Following this specific path is considered the optimal approach. And this transfer window, it has a cycle, so it comes around just once every 26 months, they say. So they're indicating plans to launch one time at the close of the year 2026, and then again following a period of 2 years and 2 months, thereby adhering to this consistent cyclical launch timetable. Otherwise, it would consume significantly more fuel and take a much more challenging route. This is considered the optimal path, the very best route to take, they say. They've set a very aggressive target for 2026 with a 50-50 chance of success. Of course, there's a high likelihood of delays. Anyway, the transfer window is set to arrive in 2026, so the plan is to launch then. And if they had launched in 2018, they would have gone to this point again. Then, after another 26 months, they'll launch again, continuing this periodic approach with attempts. A lot has been said, but to create a self-sustaining civilization on Mars, there needs to be something there even if the supply lines are cut off. So it's been estimated that approximately 1 million tons or even more of supplies will be necessary on the surface of Mars. They state that to attain complete self-reliance, where not even a single vitamin C is lacking, they'll have to continue dispatching between 1,000 and 2,000 Starships during each available launch window. So the current production scale of Starship is about 1 every 3 weeks, aiming for 1,000 per year, which means around 3 per day. They're saying they'll keep ramping up production capacity, and they are currently constructing these massive gigabays down in Texas and also in Florida. In the traditional space industry, this might seem a bit outlandish, perhaps even completely absurd, but having successfully built Tesla, he now believes that this is indeed something that can be accomplished. So, they'll need about 10 launches every single day, and since communication with the Earth is quite distant, it takes a very long time and is certainly not an easy endeavor at all. Initially, the plan is for Starship to travel to Mars, accompanied by the Optimus robot, with the aim of establishing essential infrastructure for human settlement, ultimately leading to the terraforming of the planet to make it habitable for future generations. They're planning to create a Mars version of Starlink for communication, just like Earth's Starlink, but there's a delay of at least 3.5 minutes to up to 22 minutes due to the speed of light. Regardless of how quickly they transmit it, the delay due to the speed of light must be taken into account, meaning that even at light speed there's still a duration involved. And as they build a new civilization on Mars, they are also contemplating entirely new forms of government. It's certainly on a vastly different scale. Their ultimate goal is to establish a completely self-sufficient civilization. This announcement, coming at a time when the idea of going to Mars faced considerable criticism, genuinely showcased concrete plans for what they are truly working on, highlighting the necessary technological preparations and detailing the specific endeavors they intend to undertake. It also provided me with an opportunity to learn, making it, in my opinion, a valuable and insightful presentation. Recently, they've been saying they'll be coming back from Dogecoin starting next week, and by doing so, it appears they will gradually boost it even further. But this particular endeavor is considered separate from both SpaceX and Tesla. It will be interesting to see how SpaceX continues to advance and what kind of competition this will ignite within the space industry, especially considering that China is also making significant efforts to emulate SpaceX's progress. These are things we should definitely keep an eye on as they unfold. We will have to continue to watch and see if this is simply going beyond competition between nations towards some sort of goal for all of humanity, or if it is in fact just a scam. This has been Error.